Hello students, in this session we will discuss about HART communication that is being used in data acquisition all over the companies. Okay, to start with, the full form of HART is Highway Addressable Remote Transducer. Since it is a hybrid system in which analog and digital industrial automation is being used and this is an open protocol. The best advantage of this particular protocol is that it can communicate over and above the 4 to 20 milliampere analog instrumentation current loop. So, therefore, we have advantage of 4 to 20 milliampere loop as well as overlapping digital communication over it. Now, let us discuss something about 4 to 20 milliampere current loop. 4 to 20 milliampere current loop is a system of telemetry, or you can say it is a system of instrumentation where any transmitter can send its information over a loop which varies from 4 to 20 milliamperes to the PLCs or to the data acquisition system where all the information is being logged in. Suppose we have a process where the water level or a liquid level is rising from 0% to 100%. Now, as per 4 to 20 milliampere current loop, the transmitter or the transducer attached to this particular level will give us the output from 4 milliampere to 20 milliampere. Means when the level will be at the 0% or there is a 0 level or lowest reference level, at that time its current will be 4 milliampere and the maximum level will corresponds to 20 milliampere. Accordingly, in between it will be divided linearly, that is for 50% we have the middle value of this is 20 milliampere. So, corresponding to each situation in between this there are different values of 4 to 20 milliampere current. So, it is an analog signal which varies from 4 to 20 milliampere depending upon the level of the process. So, 4 to 20 milliampere current loop is a generalized loop which connects with almost all the transducers, either they are pressure transducer, temperature, flow, you can name any one, and it is compatible with 4 to 20 milliampere loop. Okay, for the sake of temperature measurement, let us discuss with one example. Suppose we have a minimum value of a temperature that a transducer is measuring, and when that transducer is giving information to the data acquisition system, since it is compatible with 4 to 20 milliampere output, so that transmitter or transducer will generate 4 milliampere corresponding to the lowest value of temperature whatever it can measure, and up to its maximum value it will generate 20 milliampere. In between all the values of temperature will corresponds to corresponding current values. So, that is the meaning of 4 to 20 milliampere current loop. Now, there are some advantages of this loop. Very less noise is there because we are using current as a signal. It can transmit the data up to 1 kilometer. It is compatible with most of the transducer. And another example is that all the transmitters or transducers, either it is flow or temperature, they all are convert their values into the same range of 4 to 20 milliamps. Now, sometimes students have been asked that why 4 milliampere has been chosen as the lowest value. So, the reason for its choice is that if we take a 0 ampere, it means the circuit have been broken out here. So, to differentiate whether it is a broken wire or it is the minimum level, that is 0 level, the scientists have thought that let us recommend the lowest level as 4 milliampere, and 0 ampere should be recommended whenever there is a loss of electric flow of current through the loop, that is whenever there is a breakage of line then it will be 0 amps, and whenever the lowest value of that process variable, then it will be 4 milliampere. So that is the reason that we have taken 4 milliamps as the live zero of the circuit. So 4 milliamps means live zero. Live zero means minimum value of the variable. Okay, now again come back to HART communication protocol. As I have told you that it is hybrid over the 4 to 20 milliampere analog current loop. Now in this case, this blue line represents the 4 to 20 milliampere analog signal. In this diagram, it is continuously increasing. Okay, so this is analog signal. Over this signal, we have superimposed a wave shape, or we can say an FSK signal, frequency switch K, which works on the principle of frequency shift keying. That is, there are only two ranges of frequencies. One is 1200 and another is 2200 Hertz. So one frequency will represent 0 and another frequency will represent 1. Okay, so you can see here, when there is wave shape is slowly varying, we can say the signal 1 is here, and when it is varying at a faster speed, we can say this represents the signal 0. So we can superimpose a digital signal over an analog 4 to 20 milliampere line, and its amplitude is 1 milliampere peak to peak. Now what are the advantages of doing all these things? So the advantages are, we can address the tags. Address tag means whichever instrument is communicating over the line, we can tag them one address, let's say A102, something like this. So the advantage is, if tagging is there, we can easily understood which instrument is giving the information and which instrument is not giving the information. So for this reason, the diagnosis come very easy. We can also reconfigure the devices which are compatible with HART. Some instruments whose range is flexible, that is, we can use a flow meter from one range to another range. So we can configure over HART protocol itself, because it includes both analog value as well as digital signal. So there are two frequencies which have been used. One is 1200 Hertz, or we can say this is 1.2 kilohertz. This represents signal 0. Then higher frequency is 2.2 kilohertz. This represents 1. So we have already discussed the full form of HART. It is highway addressable remote transducer. So this is the most common protocol being used for smart field equipments. Field equipments means those equipments which are used in industrial floor. So we call them field equipment. HART protocol is two-way communication. It means we can send the signal from transmitter to the control room, as well as from control room to the transmitter or to the device. So this is the reason that why we are able to control the devices even at remote locations, because it gives the access over existing 4 to 20 milliampere current loops. Benefits are improvement in the plant information management system. एक टाइम ऐसा था जब इवन अराउंड लेट 80s एंड 90s हमारे पास सभी जो बड़े प्रोसेस प्लांट हुआ करते थे, उनमें सारी जो इन्फॉर्मेशन है दैट वाज बीइंग शेयर्ड ऑन 4 to 20 मिली एम्पियर करंट लूप. उस टाइम पर जब HART प्रोटोकॉल्स लेकर आए और कुछ इंस्ट्रूमेंट्स हम लोग इनके ऊपर इंस्टॉल कर रहे थे, तो सबसे बढ़िया जो एडवांटेज लगा यूज़र्स को वो ये था कि जो कंपनीज़ के अंदर ऑलरेडी 4 to 20 मिली एम्पियर करंट लूप इंस्टॉल्ड है, उसको आपको डैमेज नहीं करना है, आपको उसी के ऊपर ही अटैच कर देना है. उसी की वजह से एनालॉग जो हमारे पास लाइन ऑलरेडी अवेलेबल थी, उसी के ऊपर हमने डिजिटल डाटा ट्रांसमिशन शुरू कर दिया, एंड दैट इज़ वाई दिस इज़ हाइब्रिड वन. तो प्लांट इंफॉर्मेशन मैनेजमेंट ईजी हो गया. वी कुड कम टू नो दैट विच पर्टिकुलर इक्विपमेंट is responding, which is not. We can reconfigure them, and due to this the installation cost was also very less. The reason was we already utilized the previous existing 4 to 20 milliamp current loop, and since we can do the diagnosis in real time, so annual maintenance cost have been also reduced. Let's have more description about this signal, that how we can plot this signal so that we can conclude in terms of its wave shape also. Now, as I've already told you that peak to peak value is 1 milliampere. So it means across the zero line, half milliampere is on upper side and half milliampere is on the lower side. So it is a symmetrical sinusoidal signal. For low frequency, that is 1200 Hertz, the logic is 1, and for the higher frequency, that is 2.2 kilohertz, the logic is 0. So two different frequencies have been used to represent 0 bit and 1 bit. So that is why we call it as frequency shift key arrangement. यानी वो सिस्टम, वो मेथड जिसमें हम लोग फ्रीक्वेंसी को शिफ्ट कर देते हैं एक वैल्यू से दूसरी वैल्यू में, सो दैट इट वुड रिप्रेजेंट आइदर वी आर सेंडिंग सिग्नल 1 और वी आर सेंडिंग सिग्नल 0. Other configuration of the network are they are available two types, either point to point network or multi drop network. Point to point network means one device is communicating with other device and it is two way. Multi drop means there is a single master and it is communicating with multiple devices on the same HART line over the 4 to 20 milliampere current loop. So there are number of devices are there, so we call them multi drop network. So that is the main advantage, that it has two type of configurations, either point to point or multi drop. Now advantages as far as transmitters are concerned. Now I am using the word transmitter. What is a transmitter? Transmitter means when we have a transducer with the capability of transmitting its output over 4 to 20 milliampere or HART, we call them transmitters. So transmitter is a transducer with capability of converting any physical variable into electrical, and finally it is able to convert its output in the format of 4 to 20 milliampere and HART. It means इनको डायरेक्टली हम लोग 4 to 20 milliampere की जो लूप है उसके ऊपर कॉन्फ़िगर कर सकते हैं. तो अगर वो टेम्परेचर ट्रांसमीटर है, इट विल ऑल्सो गिव्स यू एम्बिएंट टेम्परेचर, कोल्ड जंक्शन टेम्परेचर कंपनसेशन कर सकते हैं. सेंसर की अगर ब्रेकेज हो जाए तो भी HART से हमें पता चल जाएगा, बिकॉज वी हैव टू कॉम्बिनेशन हेयर. वन इज 4 to 20 milliamps लूप, तो 0 milliampere सिग्नल आना शुरू हो जाएगा, इट मीन्स देयर इज सम ब्रेकेज. और HART के थ्रू हम इसकी एड्रेसिंग, जो कोल्ड जंक्शन कंपनसेशन है, वहाँ का एम्बिएंट टेम्परेचर कितना है उस पर्टिकुलर डिवाइस का, तो देयर इज अ टैगिंग ऑफ दैट डिवाइस. लेट्स से T106 इज द टैग नंबर ऑफ दिस पर्टिकुलर ट्रांसमीटर, एंड वी कैन हैव एन एडिशनल सेंसर near it, and we can also measure ambient temperature near this transmitter, and that can be used for the cold junction compensation for thermocouple kind of temperature transducer. Similarly, for the wall positioners, we have some kind of advantages like actual wall position feedback can be provided, adjustment for mechanical wear. Yes, due to continuous usage of the walls, sometimes there is mechanical wear and tear. उसकी वजह से उसकी जो आउटपुट है वो थोड़ी शिफ्ट हो जाती है, तो उसको रिकैलिब्रेशन जो हम लोग इसी मेथड के थ्रू कर सकते हैं. HART की जो कॉन्फ़िगरेशन है उसकी वैल्यू को हम लोग रिकैलिब्रेट कर लेते हैं, यानी जो 4 to 20 milliampere पर पहले वैल्यू आ रही थी उस वैल्यू को हम रिकैलिब्रेट कर लेते हैं जो मैकेनिकल वियर एंड टीयर की वजह से हो रही है. और HART हमें डिजिटल इसका स्टेटस बताता रहेगा, either 1 or 0. 1 means it is working fine, 0 means there is some problem. So these are some of the advantages. Individually transmitter wise. Now let's have a look what is there within the HART modem. There are some ICs available in the market. ये एनालॉग डिवाइसेस का एक IC अवेलेबल है AD5700-1. तो ये कंप्लीट HART मॉडम सोल्यूशन है हमारे पास. So we can have see RX, TX, we can have a serial port communicator which can configure it. Then we have ADC input, HART input and HART output. Now let's see what is there within this. So one is UART interface जो serial port के साथ interact करता है. Then हमें चाहिए एक FSK converter, यानी अगर हम लोग कोई input दे रहे हैं यहाँ से डिजिटल इनपुट इसको दे रहे हैं लाइक हेयर ADC इनपुट इज देयर, तो उसके अकॉर्डिंगली ये फ्रीक्वेंसी को शिफ्ट कर सके, कन्वर्ट कर सके, और तभी वो डिजिटल टू एनालॉग कन्वर्ट करके थ्रू बफर HART के ऊपर सेम आउटपुट डिलीवर करेगा, बिकॉज वी हैव टू कन्वर्ट इनटू अ साइनोसॉइडल वेरिंग फ्रीक्वेंसी सिग्नल. And it includes, now you can see we have ADC, DAC, buffer is there, some band pass filters are there, reference voltage, or within the circuit we have one small circuit is there which can control the reference voltage, and one more component is there which is oscillator, so that we can generate controlled frequencies for the HART communication. This is the final structure of complete HART as a case study. So now we have some transmitters which is getting power from 4 to 20 milliampere loop. So this is a long cable which works on the principle of 4 to 20 milliampere. So now here we have some connection so that there is no loss of current due to resistance, and after that we have HART modem that just we have studied in the last slide. It communicates with the computer through RS232 and it communicates on the line through HART. Okay, so that is how it works. Another interesting thing is we have to have one special resistance to the value of 230 ohm to 250 ohm, that depends upon the line length, but usually it ranges from 230 ohm to 250 ohms, and this is also known as terminal resistance, and it is always connected at the end so that we can have a proper current control for the given voltage signal. So that's all for 4 to 20 milliampere telemetry and HART protocol. So they both are used in industry. One is used for analog communication and HART exclusively is used for digital, but since it is implemented over the 4 to 20 milliampere, so we always call it is a hybrid system where we can send analog signal as well as digital signal. These are some of the links of the YouTube videos, you can explore more. So that's all for this session. Thanks for watching this video.